Hello everyone, in this video I'm going to talk about type compatibility in TypeScript. There are two major classes of type systems that differ in how they determine whether one type is compatible with another type. There are nominal type systems and structural type systems. It's important to mention that a single type system can use features from both of these classes. For example, Facebook's Flow uses structural typing for objects and functions, but for classes it uses nominal typing. In nominal type systems, the type system determines whether the types are compatible based on the names of the types and explicit declarations. This is a simple example in Java. We have two classes, programmer and manager. These classes have the same structure. Both of them have a single property called name of type string. Then I create a variable called person of type programmer and assign an instance of the programmer class to it. And this assignment is correct because I assign an instance of the programmer class to a variable that is expected to have the instance of programmer class. Since these classes have the same structure, I might think that I can assign an instance of a manager class to a variable of type programmer. They have the same structure, so why not? I will try it, and I will get an error, because these types actually do not match. These classes have different names. Programmer is not manager, even though they have the same structure. Let's have a look at another example. Both the programmer and manager classes have the name property. So I decided to move this similarity in a superclass and share it. I called this superclass person. Then I explicitly declared that both programmer and manager extend person. In other words, they inherit from person. Here I can assign either an instance of the programmer or an instance of the manager to the variable person, which is of type person, because I explicitly declared that both the programmer and manager extend person. If I create a class called accountant and it has the same structure as person, I wouldn't be able to assign an instance of accountant to the person variable because I did not explicitly declare that accountant is a subclass of person. Here, using the extends keyword, I said that programmer and manager are subclasses of person. I didn't say the same about the accountant. So I cannot assign an instance of accountant to a variable where an instance of a person is expected. In structural type systems, the type system determines whether the types are compatible based on the structure of the types that are compared, and the type system doesn't force explicit declarations. The TypeScript's type system is structural and it was designed based on how JavaScript is commonly used. The goal is to support JavaScript's existing features and common usage patterns. So it was chosen to develop a structural type system because it fits better with different kinds of relationships, like relationships between different components of a program found in existing JavaScript code, than a nominal type system. Now I would like to go over the type compatibility page from the TypeScript handbook. Handbook reference, type compatibility. I have introduced the TypeScript's type system already, so let's go to a note on soundness section. So what is a sound type system? It's a type system that catches every possible type error that can happen in runtime. It makes sure that an expression never evaluates to a value that is different from the value described by the expression's static type. A simple example is if you declare that a function returns a string, the type system must ensure that this function never returns anything else than a string. TypeScript allows unsound behavior in certain situations. These situations were carefully considered. This document explains different situations where unsound behavior occurs and the motivations behind it. Now I'm going to open the editor and start with a basic example to show how TypeScript's structural type system compares types. In TypeScript, type X is compatible with type Y if type Y has at least the same members as type X. Let me show you an example. I will create two classes, programmer and manager. Both of them will have a single property, name. I will create the programmer class. with property name of type string. Let's initialize the name in the constructor. Now I will create the manager class. Manager. These classes have the same structure. Both of them have a single property, name of type string. Even though these classes have different names, programmer and manager, in TypeScript they are compatible. So we can substitute one of these types for another. I will create a variable called employee of type programmer and assign an instance of the manager class to it. And this works fine because manager and programmer have the same structure. TypeScript doesn't look at the names. So to check whether a source type, in this case it's manager, can be assigned to a target type, programmer, the compiler checks each property of the target type, the programmer, to find the corresponding compatible property in the source type, manager. So to figure out if we can assign a manager to a programmer, TypeScript will check in programmer, it will check each property and find out if this property exists in manager and if this property has a compatible type. And if manager has all the properties of programmer, then it can be assigned to the programmer. So if the manager class didn't have one of the properties declared in programmer, like for example name, there will be an error. The assignment still works if the type that is being assigned has additional members. For example, I will add to the manager class a method called manage, and we still can assign an instance of manager to where an instance of programmer is expected. And this is fine because the compiler won't allow us to access any members that are not declared in the programmer class, because here we declared that employee is of type programmer. We cannot call the method manage on the employee object even though we instantiated a manager here. We can use only the common members. Here, for example, if I try to call on employee manage, there is no manage, even though we instantiated a manager class here. Now I will repeat the example of subtyping that I showed earlier using Java. Both programmer and manager have the same property, name, so we can share this feature using a superclass. Let's move the name, declaration, and assignment to employee, and declare that both programmer and manager inherit from employee. Next, I will create the accountant class that also has the name property and an additional method called audit. By looking at the structure of the accountant, we can say that accountant structurally is a subclass of employee, because accountant also has the property name with the same type. In Java, we couldn't assign accountant to employee because we didn't declare explicitly that accountant inherits from employee. But in TypeScript, we can do it, even though we did not declare that accountant inherits from employee. So I can say here employee is equal to new accountant. So in TypeScript, usually we don't need to declare relationships between types explicitly. TypeScript doesn't look at the names, it checks the structure. As long as the type that is assigned has a compatible structure, the assignment is allowed. Also, here we explicitly declared that both programmer and manager are subtypes of employee, so we can assign an instance of a programmer or manager to where an instance of employee is expected. Accountant is also considered to be a subtype of employee, because it has all the features of employee, it has the name feature, so we didn't need to declare explicitly that accountant is a subtype of employee. TypeScript figured it out for us. Same if we changed the type of employee variable to programmer, and the programmer had additional members, like for example, the program method, program, we would be able to assign accountant to programmer if we add the program method to accountant as well. Now accountant is a subtype of employee because accountant has the name property. Also accountant is a subtype of programmer, again because accountant has the name property and the method program in common with programmer. So that's basically how objects are compared. Let's look at how TypeScript compares functions. So let's look at comparing functions. Checking functions for compatibility is not so straightforward. Let's have a look at the example here. We have two functions, x and y. Function x has one parameter and function y has two parameters. The first parameter of both functions is the same, a number. Function y has one more parameter of type string. The return types are the same, 0. Then x, function x, is assigned to function y. And the assignment works, even though the function x, the source, has less parameters than the function y, the target. So let's see how this comparison happens. Here is the rule that TypeScript uses to check if one function is assignable to another. So to check if function x is assignable to y, we first look at the parameter list. Each parameter in x, here, must have a corresponding parameter in y of compatible type. So function x has a single parameter, a number, and the corresponding parameter in function y has the same type. Also note that TypeScript doesn't look at the parameter names when it compares them. Then assignment of y to x is not allowed, because function y, the function that is being assigned, has one more required parameter of type string. So why are we allowed to assign x to y, despite the fact that y has two required parameters and x has just one? The reason is that ignoring extra parameters is quite common in JavaScript. There is an example of where this happens. Here we have an array, items, and here we use a for each function to run a callback for each element in the array. And the for each callback takes three parameters, item, index, and array. And these parameters are always there. They are always provided. For example, we don't expect the index to be undefined, but usually we read just the first parameter, item, and don't care about the other two. So a common callback function for the for each function looks like this. We don't list the other parameters that we don't use. Basically, we assign a callback function that takes one parameter to where a callback with three parameters is expected. Now let's look at the return types. Again, we have two functions, x and y. Function x returns an object with the name property with value Alice, and function y returns another object with exactly the same name property, but it also has the location property. Then function y is assigned to function x, and the assignment works, because the return type of the source function y is a subtype of the return type of the target function x here. The return type of function y has a required property name, and the return type of function x has the name property of the same type. And the return type of y has an additional property called location here. So the return type of y is a subtype of x, because y has all the properties of x and also its own properties. Now let's look at the other assignment. Here they assign x to y, and this assignment doesn't work because the return type of x doesn't have all the required properties of the return type of y. It lacks the location property. So basically, the type system enforces that the source function's return type, and here the source function is y, be a subtype of the target type's return type. That's it about comparing two functions. Now let's have a look at function parameter bivariance. I will explain this concept in the editor. Okay, I'll remove this line. I will create an interface, call it my event. Let's say it describes common features of the events that occur in a user interface. Each event should have the type property of type string, which is basically the name of the event. Also, let's create a more specialized event type to describe the mouse events. I will call it my mouse event, and it inherits from my event. Let's describe the mouse location using the properties X and Y. Next, I would like to create a function that allows a programmer to listen for a specific event. I will call it listen event. The first parameter is the event name. And the second parameter is the callback function that is going to be called when the event occurs. The callback function should get the event object that describes the event, and I will describe the event parameter using a common interface, my event, because this function will allow me to register a callback for any event, for example, mouse events, keyboard events, etc. I won't implement this function, it's just an example. Now I would like to call this function to register a callback for a click event. So I specified the event name, and now I should pass the callback. And in the callback for click event, I expect the event object to be of type my mouse event. So function parameter bivariance means that when the types of function parameters are compared, assignment succeeds if either the source parameter is assignable to the target parameter or vice versa. Basically, TypeScript allows in function parameters to assign a less specialized type, my event, to a more specialized type, my mouse event. In the listen event, I can call the callback with an object of type my event, and that's it. Basically, here I assign a less specialized type to a more specialized type. And this can happen in the opposite direction as well. I can assign a more specialized type to a less specialized type. I can say my mouse event, and here I can say that I want my event, and in the function I can assign the object of type my mouse event. And this works too. So I'm assigning a more specialized type, my mouse event, to a less specialized type, my event. I will undo this change. Just to describe this pattern briefly. I described the event parameter of my callback function using a more specialized type called my mouse event, because I expect to get this object when a click event occurs. Let's say I read it in the documentation that for click events, I will get my mouse event. But actually, listen event may invoke my callback function with a less specialized type. This behavior is unsound, but allowing this behavior enables many common JavaScript patterns. So I trust listen event to pass a correct event object at runtime. You can disable this behavior if you set the compiler option strict function types to true, or if you enable the strict option, the strict function types option is enabled automatically. And I recommend enabling the strict option because it makes the code more type safe. So I will go ahead and enable it. Strict true. And now this assignment is not allowed. Now let's look at the next section of the type compatibility page. Let's look at the optional parameters and REST parameters section. TypeScript treats a REST parameter in a function as an infinite series of optional parameters. The motivation for treating a REST parameter as a series of optional parameters is again to support the common usage patterns found in JavaScript code. Before we proceed, it's important to note that by default, when comparing functions for compatibility, optional and required parameters are interchangeable. In this example, we have two functions that are the same with one exception. The parameter in function B is optional, but the parameter in function A is required. And with this difference, we can still assign function B to function A and function A to function B. However, if we set the strict option to true, we won't be able to assign A to B anymore. Also, extra optional parameters of the source type are not an error, and optional parameters of the target type without corresponding parameters in the source type are not an error. One of the examples that motivated this decision is the following common pattern of a function. I will copy and paste this code into my editor. I see this example like this. We have a function called invokeLater. What this function does is it calls a callback function with the parameters we pass using an array here. The callback's parameters are declared using the REST operator, saying that the callback can have any number of optional parameters. Then the author calls invokeLater to run a callback function with two arguments, two numbers. As a callback, the author provides a function that takes two parameters. As a programmer, I clearly see that the callback should have these two parameters. Here they are. And as long as the function works correctly, the invokeLater function, these parameters must be present in the callback function here. So I would say it's okay for me to expect that these two parameters are there in the callback. So I don't want to check if they are defined before using them. Even though here in the callback's type definition, all the parameters of the callback are optional. And here I expect them to be required. So TypeScript says, hey, as long as the developer listed the parameters here, I will consider them present. TypeScript won't give me a notice that these parameters can be undefined. To see this better, I will change the type of the REST parameter here to a number. Here, we pass a function with two required parameters, and let TypeScript to infer their types from the invokeLater's declaration here. So x and y are numbers. When we specify function parameters in TypeScript, TypeScript considers them required by default, and it infers the types for us. Basically, I can move this callback outside, say my callback, pass it here. Now TypeScript cannot infer the types of the parameters, so I have to describe them manually like this. Number and y is number, and the parameters are required by default. To make them optional, I have to explicitly declare this using a question mark. But I don't want to make them optional because I expect these parameters to be present. So allowing to pass a function with required parameters to where optional parameters are expected is unsound, because TypeScript typewise cannot guarantee that these parameters, actually these parameters in our callback, are going to be present, because invokeLater is allowed to call the callback with any number of optional parameters. And actually it can call it without any parameters, like this. And TypeScript still allows us to consider these parameters to be present. The other example here, this one, looks confusing. So if TypeScript forced us to match the optional and required parameters exactly, if TypeScript did not allow us to pass a function with required parameters where the optional parameters are expected, this code pattern would look quite confusing. Because as a programmer, I look here and I see, hey, I pass these two parameters here, then they should be present in this callback. Why should I check if they are defined? So that's how I see this example. So let's go further with the type compatibility page. Let's look at functions with overloads. I will show you an example in the editor. Here I will create a function called x with two overloads. The first overload takes a number and returns a number. The second overload takes a string and returns a string. Now I will add the implementation. It takes a parameter of type either a number or a string and returns the parameter. So this implementation matches the overloads. Now I will create another function, call it y. Basically, I will copy the implementation of function x and rename it to y. Now I will try to assign function y to function x. The type of this variable is going to be the type of the function x, and I will try to assign y to it. This assignment is not possible because y doesn't have the overloads of x. Let's try to copy these overloads to y. Okay, rename them to y. Now the assignment works because y has all the overloads of x. Together with this, y can have additional overloads. Like, for example, we can add an overload saying that y can take a boolean, and return a boolean. Now we should implement it. Okay, and the assignment still works, even though y here has more overloads than x. Let's try to make an assignment in the opposite direction. I will try to assign x to y. So I'll create a variable, call it yfunc of type y, and try to assign x to it. And this assignment is not working because x doesn't have all overloads of y. Good, now let's have a look at enums. So, enums are compatible with numbers and numbers are compatible with enums. Here the author talks about numeric enums, not string enums. And enum values from different enum types are considered incompatible. I will show the example in the editor. Okay. I will create an enum called status with two values, ready and waiting, like in the example from the page. So numeric enums are compatible with numbers. Status is a numeric enum and the value ready corresponds to number 0 and waiting to number 1. So I will create a variable of type number and try to assign a value from the status enum to it. Status ready, and this assignment works. So numeric enums are compatible with numbers. However, enum values from different enums are not compatible. I will create another enum. I will use the example from the type compatibility page. It has 3 values, red, blue, and green. Now I will create a variable and assign the value of status ready to it, which corresponds to 0. Then I will try to assign to this variable the value of color red, which also corresponds to 0. The second assignment doesn't work because color and status are different enums. So here the value of variable s is actually 0 and the value of color red is 0 as well. Then basically we try to assign 0 to a variable that has 0 already, but this assignment doesn't work because the color and the status enums are different. Okay, let's continue with the type compatibility page. Let's look at classes. Classes work similarly to object literal types and interfaces with one exception. They have both a static and an instance type. I will copy and paste this code into my editor. Okay. First, I will fix some errors because I enabled the strict option. So I need to initialize the feed property. And here there is the variable s. I declared it already here, so I will comment these lines. And here I should instantiate the classes. Cat with 4 feet and new size 4. Okay, looks fine. So these classes have the same instance type. An instance contains all public properties and methods of the corresponding class. Both of these classes have the same public property called feed. If we instantiate one of these classes, we will have an object with a single property, feed. That's why assigning class size, instance size, to where an instance of animal is expected is okay, and assigning an instance of animal to where an instance of size is expected is okay as well. It's important to note that when two instances are compared, the static members and constructors of their classes do not affect compatibility. We can clearly see that the constructors of these classes are different here. Their parameters are not compatible. And if, for example, we add a static method to one of the classes, like I will add public static hello, okay, the instances here are still compatible, even though animal class has a static method that is not present in the size class. Okay, now let's have a look at private and protected members in classes. Okay, private and protected members in classes. Private and protected members in a class affect compatibility. When an instance of a class is checked for compatibility, if the target type contains a private member, then the source type must also contain a private member that originated from the same class. I will show you an example. This is how I see it. I will create class A with a single property of type string. Let's initialize it. Okay, then I will create another class with exactly the same shape. I will call it class B. Now I will create two subclasses for A and B. And for B, so subclass of B. Now I will create the instances of both classes and subclasses. Instance of class A and instance of class B. And I will create the instances of subclasses. And subclass of B. Okay, now all of these four instances are compatible. We can assign, for example, an instance of class B to an instance of class A, or vice versa. Or, for example, an instance of subclass B to an instance of class A, and vice versa. So these instances are assignment compatible. Now let's see what happens if we add a private property to class A. Okay, I will add a private property B. Let's say a number. Let's initialize it. Now let's try to assign an instance of A to an instance of B. I will add the missing parameter here first. Okay, let's just add some number. So let's try to assign an instance of A to an instance of B. And the assignment works, even though class A has a private property that is not present in class B. Now let's try to assign an instance of class B to an instance of class A. Okay. And this doesn't work. Now I would like to read the assignment rule from the handbook again. When an instance of a class is checked for compatibility, if the target type, here, this one, contains a private member and it contains a private member, then the source type, this one, must also contain a private member that originated from the same class. And class B cannot contain a private member that originated from the same class with A, because class B is not related with A. Class B doesn't inherit from A. So if class B actually inherits from class A, I should make some adjustments to make this happen. Okay. So if class B inherits from class A, then the instance of B becomes assignment compatible with the instance of A. So we can assign instance of B to where an instance of A is expected. I will restore the example. I will make class B a class on its own. Okay, now let's see what happens if I add the same private property to class B. Now class A and class B again have the same shapes. Even the private properties name and type is the same. Let's have a look at the assignments. And this time both assignments are not allowed. The instance of class A is not assignment compatible with an instance of class B and vice versa. But an instance of a class that has private or protected members is still assignment compatible with an instance of its subclass. For example, we can assign an instance of subclass B to where an instance of class B is expected, like this. But we cannot assign an instance of subclass B to where an instance of A is expected. So we should use subclass A for class A and an instance of subclass B for class B. Finally, I will read one more statement from the handbook. This rule about private and protected members allows a class to be assignment compatible with its superclass, but not with classes from a different inheritance hierarchy, which otherwise have the same shape. So that's how I see this. Let's move further. Okay, let's look at generics. Because TypeScript is a structural type system, type parameters only affect the resulting type when consumed as part of the type of a member. So only the resulting type of a generic is checked when comparing types. Here we have an example. We have a generic interface empty with one type argument t, and it is used to describe two variables x and y. The resulting type of x is gonna be an empty object, and the same for the resulting type of y. Basically, we have two empty objects here. So x and y are compatible. And they are compatible because the type argument in the generic here is not used in a way that makes the resulting types different. If you actually use the type parameter, for example, to describe the property data here, then the resulting types of x and y are going to be different. Here, the data property in x is a number, but in y it is a string. Therefore, x and y here are not compatible. Their shapes are different. Also, here generics are compared with their type arguments specified. Actually, the resulting structures are compared. So there is a question. How does TypeScript compare generic types when the type arguments are not specified? Like in this example. We have two generic functions here, and they are compared without their type arguments specified. The compatibility in such cases is checked by specifying any for all unspecified type arguments. Then the resulting types are checked like in the previous example here. So these two functions are the same if we specify any for the type parameters. And this assignment is okay. Okay, let's move further and look at this topic, subtype versus assignment. In TypeScript, there are two kinds of compatibility, subtype and assignment. Subtype compatibility rules determine whether type A is a subtype of type B, and type B is a supertype of type A. These rules were listed in the TypeScript specification document, and this document was released a long time ago and is no longer updated. The assignment compatibility is used to figure out if one type is assignment compatible with another type in certain situations. Like for example when we need to assign a value to a variable. Again, the rules for assignment compatibility were listed in the specification document. Basically, both compatibility types share most of the rules. The difference is that the assignment compatibility includes the rules to allow assignment to and from any, and to allow assigning a number to a numeric enum and vice versa. So, based on a circumstance, the language checks whether a type is a subtype or a supertype of another type, and or it checks if a type is assignable to another type. I don't understand this statement clearly though. I need some more information or context here to figure it out. Maybe this statement means when type compatibility is mentioned, for simplicity we should just think of it as assignment compatibility. I am not sure. If you know more about it, please let me know in the comments. That's it. If you liked the video, please hit the like button and subscribe. See you next time.